Welcome, dear students, into this lesson where we will now be taking the ERC20 fungible token smart contract, which we deployed as well, written in vanilla Solidity from the previous lesson. We'll be taking it in this lesson and modifying it using Solang Solidity for it to work as a Solana program. And as well, in upcoming lesson, I think we will work to deploy it. But first, we want to modify it, and that will help you to learn a lot from vanilla Solidity to Solang Solidity. With all those things, we've learned the syntax and a lot more. Now, practicalizing it will help solidify your knowledge better. And in case you get stuck, don't forget, join the community and ask for support. We'll be there to support you. Now, the basic things that I want us to, because this thing, like I said, even though it's solidity, but you cannot just 100% copy paste a vanilla Solidity smart contract for EVM and then just slash it on Solana. So that's why Solang is coming in, because it will take you some modification here and there, but at least it's still much different from learning a new program like Rust from scratch and getting hold of it to start developing. So if we want to do that, first I would like to look at the basic things we need to know. What are the basic things? How does this smart contract, ERC20 smart contract work? What are those essential things that are needed? Then from there, we can now be able to say, okay, these are where we need to modify. I think in the previous lesson, I broke that down for you as well, that I said there are things you need, like you need a library, because you wouldn't have been able to write with maybe just 5 lines or 12 lines of code to have a smart contract run and create ERC20 token, do a lot of other things like that, mint new token and things with these simple lines of code. No, it's because we are leveraging the power of library, which is OpenCepilin ERC20 library. We imported it and then it handles a lot of other things. We just need to give it a name based on this constructor to pass the name of our token and all those things. So we've learned about that already. Now, breaking it down, we need a library as well. We had the library, then we import the library, and we can now fix in like maybe constructor and some other functions that we may want to override. So the same principle is what we want to use for the SPL token. I've said this severally, that on Solana it is called SPL token. That's Solana Program Library, which is collection of libraries and interfaces that help you to connect with already like deployed Solana program. The SPL token program is the program that has already been deployed, handling creating new token, creating accounts, and a lot of other things when you want to create a token. So for you to interact with it, we need that library to help us. And remember that Solana split the smart contract into 2 instead of 1. It split the code execution and then the data, which is non-executional aspect, separately. So when we are creating our token as well, we need to create this account, the data, the token mint account, and some things like that. And also mint on Solana doesn't just directly mean mint on EVM. Mint on EVM means you bring a new token to life, but here it refers to the actual token itself. So when you say mint, the token itself on Solana. So those are basic things to keep in mind. The first thing we want to do, just like we use Remix here, we are using Anchor, which we have learned in previous lessons. If you have not gone through, make sure you have. Then I just have this folder here, and I'm on Linux. I want to open a new terminal. Inside the terminal, I want to run anchor init, that's initialized, then the name of the project you want to. So in this case, I want us to use the same name as we did here, which was ERC20 SPL. So it was ERC20 SPL. Then we put this flag, Solidity. Without that flag, then Anchor will default to setting up your project in Rust, because that's the default. So we are not creating Rust, we are creating Solidity based Solana program. So you should set it up in Solidity, Anchor init ERC20 SPL, then enter to run the command. So this run a lot of things. We have seen it before. Try to set it up, the Anchor folder up, and a lot of things, including yarn, your dependencies, run your dependencies, and some other things like GitHub repo and more. So this usually will take a while depending on your network. So cool, my network is super fast now. So you can see that has been done within maybe a minute or two if your network is fast, but at times when I have slow network, it can go on for 5-10 minutes or even more. Here we have it now. You can see initialize empty git repo. So where we have the file, then ERC20 SPL initialized. So we have the Anchor folder initialized. Let's go right inside of it. So we cd into it. Yes. Then if I list, you can see the list of folders and files in there. So now let's open it in our code editor, which is VS Code, so that we can start editing it and working with it. Yeah, let me adjust it a bit. So I won't be running you through the files again. By now, you should have understood what it is. If not, go back and rewatch the lesson under Anchor tool. So I just want to go straight into the project. And if we come here, you can see that's already in this folder. As you can see them, the same we are seeing here. So let's check this now. We want to go into our Solidity. By default, it's just set up a basic one for us, so we don't need this. We need to clear it off. Save that. Then also it will create a test for us, as you can see it here. We don't need this also, so we'll clear it off and write a test for our own. I think that's the other one, which will be the Anchor term file. We'll also adjust some things. Space here. So the basic things here is we need the library, OpenCepilin on vanilla Solidity, the SPL library, token program library on Solana. So with Solang Solidity, instead of importing OpenCepilin, we'll be importing that. Then also, when you check this ERC20.so that we imported here, you see that it also imported some other extensions and things like that. So just a similar thing we'll be having over here. So just a similar thing. So the first thing we need to do to import here now, unlike the remix that we just import and then it locates the OpenSEPI lane and import it. No, this doesn't work that way. So we need to manually import it. So inside this, your anchor folder structure, we need to create a new folder. Let's call it libraries. So we'll call it libraries. So that we can now add those things. Here now the libraries are already available. Just want to give you an idea. If we go right to Solang Solidity doc, we have access to where they stated it about the libraries you can use. They majorly have two libraries for the Solang Solidity for Solana. One is the SPL token program library, and then the second one is the system library. That's what help you to be able to connect with the Solana for creating accounts, interacting with the blockchain and things like that. So you need both of them in our contract. So what we do already at the end, below the video under the resources, you'll get access to a full repo, that you can have and be able to have access to the library. So we need those two. Then for us to create an SPL token, we also need additional something, just like some of these were imported like I showed you. You see, metadata. So for us to have our metadata on Solana, we'll use the Metaplex MPL metadata platform to handle that. So we are having 3 libraries that we want to import. So we don't need to write all those complex code ourselves. This ones has been written for, so you don't need to bother about them. You just copy, paste them. That's it. Even in your actual reward projects, because you don't need to write them over again. So we'll have it in the repo. You'll be able to see them. So over here, I just the first one we want to create is the SPL token.so. So over here, create a new file called SPL underscore token dot so as Solidity. Then we have the code, so I will just copy paste it as well. So you'll be able to have it in the repo. So I've copied it twice because I was wondering, this signs, red sign means there are errors. So you see there are errors here. The system instruction I told you about, you couldn't find it. You see it was imported. And another thing you see that was imported is Solana. This one is default that you need to import to a lot of your reward projects to have access to a lot of built-in functions, which you have learned some built-in functions. Once you import it, then you have access to those built-in functions like message.value, transaction.account, and things like that. So that's why you have this. Then because it's default, that's why you don't need to, it's built in. But we need to also have this. So for us to have that, we need to create it, called system underscore instruction. Hope I got this spelling. Instruction dot So yeah, so once we have this, I also just need to copy paste it. Like I've told you, it's not what you need to be writing. Just copy paste it from the repo as well. Right here we have the two, the so you should have seen this already. Not sure why. Okay, so you see I just tried to comment it out, and so I think that's tried to reset it. Then it has been able to identify the last and third one to add to the list. Sorry, in the library will be the SPL underscore meta data.so. So I can just drag it because I don't know why when I copy it's just duplicating. So we have this also, this to handle the metadata. Then we have the three libraries. Now if we come here, we have the three libraries ready, the same that we have here. Just it's now for us to import it and then start making use of the libraries altogether. So the first thing we need to do, we need to import the libraries, which maybe import so we import the .so, then we import the metaplex as well. Libraries slash MPL underscore meta data.so. Good. So you can see now we import, and remember in Solang Solidity, even if we include this, it is silently ignored. It doesn't need to state the compiler, so that handles for us. So we don't need this. Then we need to, once we import that, we need to declare the contract. So, but before we do that, remember when we were learning about the features and some things that are different, is that when you are dealing with Solana, you need to specify the program ID. That's like when you deploy your smart contract, it always have an address of its own, just like also on EVM, Ethereum. So the same, you have it, and it's very essential you have it stated so that each time the contract is being run, it's the contract is dealing with and some other things like that. So to have that, we have program underscore ID. Then we have an address. So let me just copy one address here for us. After that, remember, we can now start declaring our contracts. So here now the name, let's give it ERC20 SPL as the name, then the code. So you see the error has disappeared. So every other thing we want to write now, code will come in within this our contracts code. Everything will come in here. So unlike the remix, you can't just, maybe it's just some error. It's not just going to be auto-compiling for you. So then the next thing we need to do is, remember, you need a payer, because compared to Ethereum, directly the wallet that is interacting on EVM will pay for fee, but on Solana it goes even beyond that, because if you want to set up an ERC20 token equivalent, which is SPL token, you will need to pay. You know, we have two accounts: the executable account, which carry the code for the smart contract, and the data account. And for you to have data account, you have to pay rent. So that rent, it depends on the data that's there. So that's why you will need to it will deduct some so from the payer wallet, then use it to create the account and pay, deposit the rent and things like that, to be able to store whatever you want to save. So that's why we need to specify the payer. Then the next one will be the constructor. So annotation should precede constructor or other items. So these things also help you to know where you are going wrong. And remember, we've dealt with this constructor severally. So you have, so for now, if we have anything like this that we need to pass in, then we'll pass it in. But I think based on the SPL, so it doesn't have, it says library, it doesn't have the constructor, so we don't need to pass any constructor argument to it. Just a struct, function, and enum. And you see, that was enum we learned. This is a real world project. You can see how it was done. 0, 1, 2. That enum is like representing, instead of all this writing it as individual variable, you can just pack them in one and then refer to them as well by the index from 0, 1, 2 as much as possible. So make things neater compared to structs. That is, I think we have another struct example. So you see, this is key value pair. The like uint, that's the data type, and then the name, like maybe it's instruction or whatever. So that's why I'm picking up this Spotlight project along our courses, to ensure as you have learned those syntax, you can easily forget, but by the time you start seeing them in real world projects, then it will start sticking more to you. So we don't have any constructor to pass, so that's why we will leave this empty. Then the next one we want to do, we just want to create the token and then mint. And like I told you, on Ethereum, once we set this up, all we need is just to mint, connect with the blockchain, and then mint the account, deploy the smart contract, start minting, and all those things will be charged within this smart contract. But on Solana, it doesn't work that way. It won't be charged directly like that. So first, you remember, it's two that you need to create. You need, for the code that we are running now, they need this to create a data account that will hold the data aspect of the code of our program, Solana program or Solana smart contract. Now, aside from that, when you are dealing with this mint, there's with the SPL token program, it need to also mint out a kind of mint account, and then the account that will track it, so that we can know that instead of inside this, if we go here, let me check. If we go here, we have mapping, yeah, that are tracking this thing. So instead of this mapping that track every of the token, who owns this, who owns that, there is this mint account that help you track the same on Solana. So that's what need to be created. Then you mint, you can now begin to mint your token. If not, your token will be lost because it can't be tracked. By default, Solana only is able to track the default token, coin, which is SO, just like Ethereum. Ethereum by default don't just track custom token. That's why inside your smart contract, you need to track it yourself. You need to create a saved and map what's the address, what's this, then that you see, you track the balances yourself. Then that's what makes it available, makes it trackable, that okay, a wallet has this token, we have total supply of the token as you can see it. So you need to track every of these things individually. But a lot of those things has been done with the help of the SPL token. You don't need to track them individually with mapping and all those things. But in order to have access to that feature, you also need to create that specific mint account. So all those things will be done for us because we just need to reach out to the SPL token, create a mint account. That's create a token, then create a token tracking account for me to track and manage this token. So that's what that will be about. So the next thing we will need to do is for us to create a function to mint, and in that function, let's go here. If I come right here, let's go down, struct, you say initialize mint, then you have create mint. Yeah, you can see this function now. You create a mint. So this undo everything. You need to pass in payer, the mint sent to the account to be created, the land port, the program owner and authority, and a lot of things like that. As you can see them that they are passed here. Let me highlight it for you. See address payer, mint authority, address freeze authority. So all these are what we need to as well pass into our function. So we are going to create a function that will be called create mint token. So I'll just paste them here so we don't need to be typing it one after the other. Like I said, you have the repo for you to work with as well. So let me just have it and then I will explain. Don't be confused. So if you look at this now, this function say create token mint, then you pass address, payer, mint, authority. So the payer, that's the account that will handle the pay as we have passed it also here. Then we have the mint. Remember I told you on AVM, when you hear mint, that means you bring a new token to life, but mint actually refers to the token itself on Solana. A bit confusing, but with time you will get used to it. Then the token authority or the mint authority, which is who has the authority to also mint the mint itself, to handle all those things that have to relate with it. Then the freeze authority, you can freeze the token. Which account do you want to give that authority to? Then you have the metadata, that's the name, the sticker and things like that, and some other things. Then the decimal. I told you on Ethereum default is 18, but Solana is 9. So then you now have the name of your name for the metadata account, then the symbol, and then the URL that will be pointed to. So the name will eventually for token and things like that. So that's what this function is. Just all these are just arguments. You can see it right here. Are just arguments you want to pass in. Then this is a public function, which means it's publicly accessible within and outside the contract. Then inside the block of code of the function, you now run these two functions. And remember, we have imported this. And before I forget, you remember we created 3, but why are we importing 2? We only imported 2 because this particular SPL token has imported and make use of the system instruction. So we don't need to import it again. So we just import this and then we inherit everything it has also imported to work. So we don't need to work on that individually. So here now we have that passed. Then we have this SPL create mint, which is this I showed you earlier. You can see this was what I was telling you. When you call it, create associated token account. So that account that serves as the same thing like this mapping. And that's why I'm trying to modify it and give you the understanding. This mapping, instead that we don't have that, is this associated token account. So it's associated to your token, just like your mapping is not the actual token. It's just associated to it to be able to make it easy to track where is the token, so that it doesn't just get lost and become orphan on the blockchain. So the same is what the purpose of this associated token account serves for us. It helps us to track, make it easy and able to track, and then send token from one people to another on Solana. So all this, you initiate those accounts you need to write with the account meta that we need. You can see token account is writable through a signer. Is false. Then the mint is writable, is signer, is false. Then owner is writable, is signer. Then rent address is writable. So all these basic things are there for you to, but remember I told you, you don't need to write all this yourself. It has been written. I'm just trying to give an explanation so that you have deep understanding about it. Then you create the associated token. When you initialize the mint, that's you initialize the token. Then you now create the associated token. It seems I have a diagram. Let me try and check for you. Yeah, good. Let me see if I can zoom this. Yeah. Good, you can see it now that this you here, we are the one doing this. We discussed with this token program, that's to create, mint, transfer token and all those things. So user interact with token program via command line interface, or inside there now we are doing it through code, through Anchor. So we interact with this, and these are what we need to do. Token program interact with token, create, mint, transfer. So it creates the mint or the token, and then we also create associated token with it. It's created to hold supply. You get what I'm saying now? So I think this actually it's helpful. Maybe if I remember, I can also add it below the course video. Yeah. but you can as well get it on the Program University, one of the previous articles I've written. So you have this helpful chart for you. I think it's so helpful. Here you can have the token program, then you have the mapping, just like you have it over here. Yeah, that mapping. Then in that case, this is what you are having here. It creates the mapping, which is on Solana, another separate account called as token associated account or associated token account. So once both, then you can now start minting, doing all those things, and being able to track what are the total available supply, who owns this, and things like that. So that's the cycle. So assuming it's just on Ethereum, you just have this, create a smart contract, and then inside it you have the mapping, you have everything. You don't need to separate it, and then right away you can start tracking. So it's keep both of these and just go to you tracking that, because everything both here has been embedded into the smart contract, and you are not having a token program like that just to interact with. Though you have the features on this blockchain that makes it possible to deploy that. So I hope you get it. If you have any question, get confused, don't forget to join the community and ask. So I think that was helpful for us. Let's get back here. So that serves as the mapping. I hope you get it now. So that's what this associated token account is for. So it creates that for us, and we need to pay rent and all those things as well. So then we move to the initialize mint. So we initialize the mint. Yeah, then this is the function that we have, the create mint. You can see it now. That's what we are having here. Let me move this here. You see, create mint. So we need to pass this argument, the payer mint, mint authority, phrase, and the decimal. So as expected here. So we pass it in to the, you see that this was using the system instruction, which is this, and this undo it. You don't need to bother much, but it's good as a developer when you have idea, because at times you may want to modify or customize some of this function by overriding some things here. So by going a bit depth into them, you get, it makes things just super easy for you to modify and customize to your taste. So that's the function we are calling here inside this particular function. So as this function pass this in, feed the payer, the mint, the phrase, the decimal, then this for the name, symbol, and all those things. This will be for the Metaplex metadata library that help us handle the name, the things, and some other things like that. So we fix this one inside of it. So that's the major. One more thing to add, there are other functions, as you can see it here, depending on those you want. Maybe it might be part of the project to do. I'm coming. So once you have, you can see this undo the total supply, get balance, bond, transfer, mint to. So we need to mint. If you want to mint, we will interact with this function. So all this has already been written. We are just passing the value. So if you see, you see that all this function, none of it has a function body like the normal block of code. You see, it doesn't have function body. We are just passing it in because this already have the function for us to work on. You can see. So we are just passing the value, just like you are passing the value the same way we did with Remix. Yeah. You see, we are just passing the value. So that's why the smart contract was so small. I'm like, wow, it's just a few lines of code. So those are the things that makes it possible for us. The same here, we are just passing it, and the metaplex as well. You can see the metaplex as well as have all those things we need to pass in. The symbol, the all those things, name, and all those things are there. So we just pass it in. Here now we have the one I want to add more. That's for us to mint. So it's just for us to be able to mint to a wallet. So I will do the same, just have it here and explain it. So this mint to will be interacting with this function which handle everything we need, but for us to use it, we need to send in the mint, which is an address, the account address, the authority, which also an address, then the amount of the token to be minted into the wallet. So, and that's what we pass in here. And you see, we call this function SPL token dots. So remember when we are talking about how you call, when you inherit, how you call functions from that where you inherited it. So it is based on how you imported it. Assuming we imported this and say import something like this. Let's say import create mint. You understand? Things like that, or as create mint and things. So the way we reference it, we don't need this pause and all those things. But these are tested and proven way to just do it. So you just have access to everything inside here. So now I think I'm trying to break it down so that you can see that taking the time to have learned those syntax actually wasn't a waste of time. So the only thing why I say a lot of developers take training courses is for beginners, like, oh, you don't need syntax. You need it, because if you are not aware of these basic things, the only thing is, don't be overwhelmed by it. Don't struggle to know them. Just have the idea, so that then after that, start taking different projects head on. The more you stick with those projects, the more you do those projects, the more you see a lot of those things in action, then the more they stick to you. You understand? So we have that set, and that's all we need. You see, it's almost as similar to this, because everything has been handled by the library for us. So we are done with this. You can save it, and I can close this once. Then the next one we want to move to is the test. So the test with Anchor is for us to be able to interact with the smart contracts just like a front end, but to test those features out. So, like Remix now, once we deploy, everything is just there. We can interact. They have built an interface for us. I think Solana also have this type of online interface, but presently, as at the time I do this video, I don't know in future when you'll be watching, it doesn't support Solang Solidity. So we couldn't, I would have said we should use it to see, but it's cool, because most time when you want to build advanced smart contracts, you'll be using Anchor and things like that. So learning it as well will help you along the way. So the next one is that test, which is like a TypeScript for you to interact with the smart contract. So a lot of things will be, what I will do is I will just copy the code here, like the repo will be added below under the resources. So mainly I won't be going too deep inside this test, because in future, this totally to know how to write tests and things like that, totally in future, maybe if I will be doing a course on Anchor, then we'll learn more about how this was actually written, how you write text and things like that. But for now, we just have it over and I explain some basic things in there for you. So here we go, we import the anchor, then we import our program as well, then SPL token minter from this target. This target now, you will notice that over here we don't have any folder. If I minimize this, yeah, there is no folder here called target. So that will be auto-created for us by the time we want to run the deploy, build, and all those things. So don't worry if this is saying not found. By the time we do that, build, then it will create it for us. So I want to know those folder I'm working on. Yeah. So that's how this will be created. Then remember the system program and some other things like that. We import this from Web3.js. So this is a library which help you to interact with smart contracts on AVMs and other blockchain like Solana with the front end. Then don't forget the Metaplex that we use. So we import that as well. So then import asset token program ID. You remember that we created for the token. Then other things from Solana at Solana SPL token. So all these are already libraries for you. That's why it's saying it's not found. So we'll fix that. Then this gives us what we actually want to. This our actual token that we want to work with. So you have it describe the token, the smart contract that we are working with there. Then, so over here now, since I copied this, we need to change it to the name that we have. So I want to see if there's multiple occurrences. So I think it only occur once. So we need to change that to ERC20 SPL. Then this we configure the client. We'll still get to that. So the client, this we try to get the like a provider in terms of are you using local DevNet, the DevNet, the testnet, or the mainnet. So these are all the things that we use to configure it with the KPI. If you remember, that's why I took time to take these things step by step. So I want to believe you didn't skip any of the lessons. So you'd have seen where we set up the environment, the development environment for Solang Solidity on Solana, where we do the airdrop. We got airdrop, we set up wallet and things like that. So all these are what will be picked up because they are needed here. Then we need the token, the title of the token. So over here, we're going to change that to the token, your own title. So over here, we used this is what we used here. And then right here, we use ERC SPL. Yeah. So we use ERC SPL. Then the next one we want to adjust is the token URI. This token URI, how do you create it? I will also give you some explanation. So this one is like the raw of your file. So it helps you to know how do you do that. So I will add a resources down below that shows how this was actually created. But if you want to create it, all you have to do is to create a JSON file. You create a new file, SPL token.json. Let me just drag this here. You can see it. So once you create this file, it will contain the same detail you want in here. So it will contain this. And you copy this as well. So you can see it now. So it's just this SPL token.json file. Then you will reference it here. You can see it. So this is from raw. So how do you get about it? Once you have this, you push this particular project to GitHub. Then on GitHub, you go and get the raw file of it. So I said I will link for you to check how I did that. So you go and get the raw file of this. With that raw file, that's where you get the link to come and add it. So you see that it's purely just referring to the SPL token JSON. So I'm coming, let's follow this link then. Yeah. Do you see it now? So how did this work? So you can see you'll be able to go to this and use this same GitHub repo is there. I just updated it to I think 3.2. So you will see it here. This is it. SPL token JSON. You can see the same thing. If you open this now, by default, this is how it will display. So for you to get this link that you use, all you have to do is to click on this raw. You can see me. Just click on raw. Then it will show the raw format. And then you will notice that as we did that, let's go back. Let me show you that. You can see the URL here is the normal GitHub. But when you click raw, the URL will change. Do you see it? raw.github user content, then all those other things. That's what you need to copy to come and paste it. So as simple as that. So that's how you create this precise metadata. The only thing left is just your image. So you know where to host your image or whatever to make sure the image. So for this, I think if we open it, yeah, it's Solana shiny coin. So you can see, so you can change this here, right here before you push it. So you can see it. Just host where you have your image, put it here, preferably like PNG, not too big anyway. Then you give the description. You can see that it's the same thing we have here. So you give the description, but you see I've changed the name, but you see this name here. So you can always adjust this. Once you push it, remember, push to GitHub repo, go to the token.json, and then click on it. It comes like this, then click on raw. You see it's token.json, then click on raw. You get this address. You can now make use of it inside here. So those are the major things you will need to change over here. So those are the major things you need to change. So once we run this, a lot of those errors will be off. So then this is initialized. Like I told you in the course, I will still look at probably doing that. So you learn the basic, just like you learned basic of Solang. Then from there, it helps you when you jump the basic. I know everybody is being hyped to want to build the next biggest smart contract, but you don't know the basic. That's why a lot, even when you do, it's not easy. That's the so this helps us to initialize data account for program, which is required by Solang. So then this creates the SPL token with metadata and some things like that. Then create the token mint with payer, mint, and all those things we pass. Remember, this is just recreating what we have gotten from our all this. So it's trying to create the contract to ensure you can test it. So it's not that we are creating anything that will affect here. We are only creating things that could make it test everything we have here and deploy and mint and all those things. So the same for all this, you create the mint, then wallet associated token address for mint. So this, you can now mint your token. So this will help you to handle the minting of the token as well. So which are like the basic function we also added here, mint to. So those are the basic things there. In the repo, you will see it as well for you. If you get stuck, need help, you can always get into the Discord for support. We'll be there to support you. So we have that. I just want us to fix up the files first. Then the next one, sorry for any background noise coming from the neighborhood. The next one is the anchor tom.tom file. So we need to also fix some basic things inside of there so that it can work well for us. So we have the features, the seed, like all this, maybe in that anchor course, beginner course as well, I will explain more in depth, but for now just understand the feature, the seed, all these are false. Then program, this indicate are we using localnet or devnet. You understand? You see that this also to create the name of the smart contract we want to deploy and fix a default wallet. So let's just copy and go and use this as well over here. So because they have to be the same, but don't worry, we actually get our own for this program once we use the build and deploy and all those things. So we deploy. So for now, just always make sure they are the same anyway. So then we want to change this. We want to use devnet. So you change it to devnet. Then the registry as well is okay. Then the provider, the cluster we are using on Solana, they are called cluster. Cluster is like multiple when you have what's it called, like node, yeah, multiple nodes and all those things running the blockchain. So we need the devnet, not localnet, sorry. So then the wallet, so this is where your wallet would have been if you have followed the setup normal. So we just have it here. You have the wallet here. So for the usually this, in case you to be on the safer side, you can adjust this to so that it will locate it for you. Because if you just copy this now, your own system and things might not be named PostK and things like that. So if we have this sign, it's able to locate this, at least on my Linux. Then the next one we have here is the script. So this script, now this is it, this TS script that we wrote here, that we use to test. So this helps us undo how it will be run. So how the test will be run. Then we have some other things as well that we can add to make things much. Let me just copy them because they are usually the same like that. So it's not something you need to adjust here and there. I will explain it for you, don't worry. So the test, usually you don't need this, but at times you will notice when you are testing, maybe the node run before, or the test, run before maybe your deployment is complete or something. So that's why you need to give timing to wait more. And then once you are done with the testing, you also shut down. So that's what this is about. Then you have the test validator, which is devnet. If it is mainnet, you have as mainnet, also here as mainnet. Then the test validator clone. So this, like, you are cloning a kind of a program that exists already to be able to have access to use it. That's for the, I think, the Metaplex or something like that. So this, it's now we have the test also perfectly done. Then the next one we want to move on to is the package JSON. The package JSON, for us to adjust it, you wonder why we are doing all this, because that's the IDE has done a lot of this behind the scene for us. So, but since this anchor is just like you are using a lot of other tools as well to build, not using the browser-based Remix IDE to build on Ethereum. So like add art and things like that, you will need all this configuration as well. Your package, the JSON. So we already have the script. Then we have the dependency. So these dependency for now are not complete because we need more to run based on the things we imported. Remember, we imported this Metaplex, all these things, so we need to have them included. So for us to do that, let me add them for us over here. Yeah, so we need the Metaplex Foundation, the project. This anchor was previously, they used Project Serum. I think they are now using GraX, but this was added for like backward compatibility. But now most are Cora-XYZ/anchor. So you see that this version 26 and then 28. Then Solana SPL token, remember the SPL token, then the Web3.js. So you see that we have all those things here, and most of them are like telling us they are not available. So we have the JSON, let's close that. The Atom anchor is settled. So this also, those are the basic ones that is needed, except you add any other thing. But for the SPL token, you are good to go with this. So you can save that. And the next one we are going to now look at, okay, we have looked at the JSON. These ones are okay, just by default generated. So just leave them as it is. They are always okay. I think this help you with your TypeScript and are pre-set up by the time we set up the anchor in it, we initialize it. So we have this now. Let's open terminal because everything is set up. We have the libraries set up. We have our Solang Solidity smart contract for the SPL fungible token, equivalent of ERC20 token on EVM for Solana. So we have all those set. We have the test to test it, like deploy, build, and do all those things. Then this is it, everything is set. The anchor, the package, JSON, the JSON for the metadata, then all these ones are on as well. So the next thing now is to go to terminal, new terminal. What we want to do first is to yarn install So when you yarn install, you want to run all the dependencies. So you can do that first, and at the same time, you can try to build. You can try to build so that we have this, for example, fixed. Then we can now yarn install, so every other thing we need can be fixed. So let's try that. You use anchor build. So what this does is it like compile your smart contract, just like when you are using this. You remember we had to mark auto compile, so we need the compiler, which is Solang, to now take over and help us compile the Solidity code to be able to make it workable on Solana. So that's what the build will do, and by doing that, it will generate this target folder, the types, and then this will be fixed. So let's see. So did you notice it, that it generates target? You see, this wasn't there before, and it tells us that if there's any error here, you see it found all those library one by one. You see it, library found. So in case anyone is missing, you have error, try to check it over. So you should have something like this, and then the targets, let's quickly check. You see the deploy.so, that one is off. Target, so to undo, then this IDL is what is used by Anchor to create that code that will make it possible to interact with the smart Solana program from your front end. So if you look at it, it just generates the code ideally for the smart contract. You can see it, the instructions and everything are there. Create, token, mint, all those. Then when you now go inside this type, can you see it? So this type as well creates. So at times these things just don't fix easily themselves. So we have targets, types. Oh, there's an error here. Okay. You remember when we copied this, it's having SPL token, so we change it here. So we ought to change that name as well. So for you to get it, I can just delete this. Don't worry, once you run the build again, it will always regenerate. So this will be so at times your comments you do, it can help to refresh it. So when you see now we have this, so let's now run this again. Let me clear. Then let's run the anchor build. Anchor build again. So you see it, and then the target has been recreated for us. Then we go to the type. Then you see that instantly this has been found. You see it, that this has been resolved for us. Then the next one we want to have is this SPL token. All these ones that are not also, let's try and fix them. So now to do that, we do the yarn install, but also we need inside there, we need this address, so we need to be able to deploy to have those ones. So this test doesn't have anything to do with your smart contract deployment, build deployment. This is just testing, so we can go ahead to try to deploy and see if there's any error. If there's no error, this will succeed. So before we do that, let's check Solana balance to be sure we have enough balance. If you don't have enough balance, you can Solana airdrop. This usually take about 2 sols or so, because remember it will create a data account, pay rent and things like that. So you need to have more than one. If you have one, so it may not work, it will be showing error. So airdrop, I think max I used to collect, if we go to 5 it will be error. So max 4, I think 4 should be okay for us to even, so you can see 16. If I run the balance again, and I have 116, good. So here now I can now run anchor deploy. Yeah, so this is what will now take everything, you know, you have built it, that means you have compiled it. That's why I said it's the same. That's why I take you step by step. And if you like me upcoming videos and courses as well, to take it like this, checking it with vanilla and helping you get better understanding, especially if you have knowledge of vanilla. If this has been helpful, please let me know. It's helped me to know where to adjust and things like that. So, and double down on those that are working. So you see, just like when you compile, you don't have any issue. Then the next thing, which is the build we did here, you are building, is to deploy. So you still have to deploy. So that's what this anchor does for us to deploy to the actual blockchain. Let's try that and see if we got any error. Good. So deploy sources, you can see it. So like I told you, some will be worried, how do I get the program ID? Just put any program ID there when you are starting. It will initially be ignored. It is when you want to also deal with the front end and all those things that will be needed. You understand, the test. So it's not that it's needed when you initially want to deploy. Yeah, because if you have not deployed, how do you get the wallet? So let's copy this. The DevNet, it make use of, you see, the upgrade authority, deploy program parts. Then this, we need to copy this and then make sure we go and replace it inside this token. Then we place it with the actual one. So this is it, you can see. Then we also go inside the tests as well and replace it here. No, sorry, it's not the test, it's inside anchor term. So that know the actual smart contract. You can have multiple contracts here, so you can list them here. So programs. Yeah, so you know the ones is dealing with on the DevNet. So this is it now. This help it to like locate that program and interact with it. So go, we have all this done successfully. We have been able to compile and deploy. That's build and deploy. The same thing we did here. And now it's time to like test this, like mint, and see the token live. So for us to do that, we need to run tests. Like I've told you, they have built this interface to make things easier, but that isn't here for us. So we need to anchor run test. So usually now we ought to do the yarn, because we are now dealing with this. All these errors like this need to go. So, but I just want to show it to you to have idea. If you run this now, there's another command which is anchor test. Don't use that now. You use that when you want to do the whole three together. You want to build, you want to deploy, and you want to test. So, but when you are doing it step by step, you don't run the three. If I run it now, you will see it will build, redeploy, and then run the test. So I just want to run the test only. So if you want to build only, just use the build. If, for example, if we make any adjustment to this smart contract now, we need to use the build to rebuild again. You understand? Then if we want to redeploy and things like that. So that's why I put run test. If you just do anchor test, then to do the 3. But this means you should just run test only. So let's see. We ought to do, you see, we ought to do the yarn to make sure we fix all this. Like I told you, but I just want you to see it. So in case you see something like that, yarn install. So depending on your network, could take a minute or 2 or 5 or 10 or more minutes, depending on the network. So all this need to be installed. So it's just like a minute or 2 because network is fast now. Then you can do it again to try to confirm. So you see that I said it's already up to date. So, and it's no more installing. So you see that a lot of all these things are already done, settled. So we still have this error. Let's try it. It might be in the naming because we copied, so we might need to adjust this as well. And we'll just move on to final. We have deployed it already and then test it with Anchor. We have deployed just to test things now. So that's it for this lesson. We've been able to modify it successfully. We have deployed the contract. So it has been successful, as you can see it. It has been deployed successfully. And the only thing left for us now is just trying to test it as well, like interact with it. So in next one, we also check the deployment, something where it has been deployed and things like that. So see you in the next lesson. Keep the program sweet and alive. Your assurance to succeed as a programmer in the long term. I remain Solomon Foske. Peace and bye.